Hey Sugandar, how you doing? You okay?
Yeah, hi Luke. I'm doing good. How about you?
I am good, thank you very much. I know we've not spoke since before the Christmas break, so hopefully you had a good holiday and a good New Year. But how are you? How's things?
Oh yeah, we had a good vacation. We were in Canary Islands in Lanzarote, so it was amazing trip and good weather. And now back to work, back to
Yeah, the cold.
US schedule. Yeah, and also cold one. Yes, that's true. Yeah.
Perfect. Okay, well, before we jump into the podcast, you just want to give a very brief introduction to yourself, just so our listeners ultimately know who I'm talking with today.
Yeah, sure. So my name is Sugandar Swetharanyam. I'm from India, born and brought up in Bangalore. I have around 20 years of experience in automotive industry. Had career spanning from Bosch, KPIT, had my own company, and then later now in DXC Luxoft, working as a senior engineering director. Yeah.
Perfect. Yeah, I'm really excited about this episode today because you've had quite a unique career path and route, which I think will be of great interest to our listeners, as which we'll break down later on. But jumping right into it, I suppose, do you want to give a brief overview of who are you outside of work? What do you enjoy doing when you've not got that work commitment?
Yeah, sure. Some of the things which I do outside of work is amateur astronomy. So I have some big telescopes which I take around. I started this when I was in Bangalore, attended even a course along with my wife, and so it's a hobby which we share.
Oh, nice.
Um, and yeah, try to look at galaxies. And recently we even saw the Atlas comet, which comes once in 80,000 years or so. Yeah, so
Wow.
yeah,
Well,
it's
yeah,
something.
fantastic. And as I said, you're the man with obviously astronomy. Obviously, we won't go into the thing. I know with revelations on UFOs and all the already here and stuff. We won't discuss that today, but I imagine hopefully you're well informed on that. So I'll pull you in on that later on over the podcast. Perfect. Okay, so literally in the automotive industry, but huge fan of astronomy and space. Yeah, fantastic. The never-ending string of sites, which is great. I also know obviously family takes up a lot of your time. So what's the overview there? Like literally, have you daughters, children?
Yeah,
What's going on?
yeah, exactly. And so I'm married, and obviously I have a daughter of 10 years old, and
Nice.
she's quite excited about her school, her friends, and also we also engage a lot together in games. So I play a lot of
Hmm.
strategy games, and along with my daughter as well, we play on Nintendo. Yeah, so that's
Perfect.
quite nice. Yeah.
Fantastic. Great. Well, thanks for that brief overview. We'll jump right into the career story so far then. So, for our listeners, do you want to give a brief overview of like your education and what you did and where you were before you entered into the working world?
Yeah, sure. So I studied in Bangalore. I did my engineering in electronics and communication. Then I started working for a company in Chennai. It was called DAX, but later acquired by Siemens.
Hmm.
They were into home automation. So I worked there for a year as hardware and firmware engineer in
Hmm.
the R&D group. Interesting place where I really learned, I would say, hardcore engineering, and
Hmm.
also it helped me to realize that I'm a good engineer as well. Because you learn a lot in college, but you're not sure that you are able to apply that and you're able to explore it. So that's good. Then later, I joined Bosch. I worked there for almost 6 years.
Nice.
Started working on powertrain and other technologies. From Bosch, then I joined a company called KPIT, where I spent almost 8 years. I was in India, and then I made the switch from India to Germany. I relocated, and I'm staying in Germany from 2012. So it's quite a long time. And then I had my own company for a brief period into IoT and a lot of software services. And then joined DXC Luxoft, and now heading the in-vehicle platform clusters within DXC Luxoft.
Nice. Okay. That's obviously quite interesting career development there. And obviously the motivation with making your own startup and then going back to the automotive field is very interesting. Congratulations to anyone who makes that move, set up your own business. I can imagine it's certainly a very difficult field to enter into in the manufacturing and product development field, which is great. Okay. And within Luxoft / DXC now, just a bit more of you, like obviously your role, what are you responsible for? What is it you actually cover day to day?
On the in-vehicle platform cluster, we basically look at, I would say, mostly platform areas. So right from e-architecture, like building the whole network of a car, or even the software, which is built per ECU, I would say, within the car. So we focus on that. And also a lot of body motion and electronics and electrification activities which happen within the car, which is predominantly spread out around the car. So all these areas, we have competent engineers, our engineering powerhouse, which we build in different locations. That's my job, to look at where these engineering skills can be built and deliver the best value to our customers. Yeah.
Perfect. Okay. A very interesting role. And it's a global role as well, isn't it? I know you're very humble, but it's a very interesting job, which is great.
That's true. We have around 700 plus engineers spread across 22 countries. So nice. You can imagine, almost everywhere around the globe we are present. And in terms of even our customers, I would say, whether it is OEMs or tier ones within the automotive industry, or even manufacturing industry, and also in defense industries, where we are supporting this platform software completely.
Nice. Okay, great. And then from your side there, briefly, because I know obviously you've obviously been in the automotive period for a time, you then slipped your stop and then you came back. From your viewpoint, what has led you to primarily develop a career within the automotive space? Like, what has led you to enter the industry and then be there for so long, in your opinion?
So I think automotive industry was, I think I told you that I was working for home automation in the beginning. And then I moved to Bosch. That was more I would say, coincidence, because I wanted to move back to Bangalore from Chennai, where my then girlfriend and now my wife was working. So I shifted to Bangalore for that reason, and I landed in automotive. This was not a planned career move, I would say. But then within Bosch, I learned a lot, especially about mechatronics, which was, I was amazed. I was not aware that there is so much of software and electronics happening within car. I have to say that was the time somewhere in 2005, 2006. Yeah. The mobility sector, because in my family, my father was already into building rocket engines and so on. So he was in the manufacturing sector. And even my uncle, he was part of ISRO, part of all the space machines. Especially he was the project director for the Mars machine, which was sent and quite successful. And so we are basically engineers in the family.
Nice. It runs in the blood, as one would say.
Yeah, exactly. And then this engineering passion I was really following through, and then I stumbled upon automotive and figured out, there is a lot of complex engineering which is happening within automotive. And then from then on, I've been with automotive industry for a long time.
That's probably fair to say it wasn't a planned move then. It was kind of almost like career opportunity appeared accidentally, and then there was stuff within the space that you were aware of. Obviously, there's a large amount of mechatronics from the outside in, and then from within there, it's kind of kept and grasped you, obviously due to the innovation of the vehicles and all the different opportunities there, which is always great to hear. It kind of goes against the idea. Sometimes everyone thinks that you have to be a petrol head, don't you, to initially end up in the industry? But you're an example of many people who've came in coincidentally, but then fell in love with the space and gone on to have great careers. And I think that's a fantastic example to see there. How did you go on?
But I have to say one thing. You mentioned about petrol head, but once you are part of the industry, you become a petrol head, right? Now I look at the car, and then you look at the horsepower, what it produces, and so on. Yeah, but that's true.
Perfect. So, quick one, how were the family about us? Did you come from a family of space engineers and they're loving that space? How did they feel when you went to automotive? Were they happy, or were they a bit upset that you didn't carry on with in the space field as an engineer?
They were happy, and it's also, as I said, sometimes I speak within our family, and then we talk about the engineering which happens, and they're also amazed, and they were also not aware of a lot of engineering which goes through. Like I sometimes take the example of airbags and talk about, like, the whole airbag gets deployed within 70 microseconds, and this becomes a conversation. Like, how is it really done? How can you control things which are in such short time?
Perfect. Okay, good to hear.
it's a good conversation within the family, I have to say.
Good. Okay. And obviously, fantastic. It's a family of engineers. Great. Which lovely to see. And like you're probably third or fourth generation, so carrying on that, which is fantastic. Next questionnaire then is achievements. So from your viewpoint, there, looking back at your career that you followed, what are the key achievements / highlights of your career? What are the things you've worked on that you're most proud of or been involved in?
If I go from company to company, so I would say the first company where I worked, I built a passive repeater. As I said, it helped me in really realizing the engineering potential which I had, and that was a big achievement. And then I moved to Bosch, and then there, obviously, I learned about the industry, but I also learned about how to work with people, especially Bosch is a huge organization, yeah, and you tend to work with large group of people to achieve some larger goals. And coming out of college or as a freshman, you are mostly into yourself, and you have to figure out how to work with other people. Yeah, so that's a big learning and achievement, I would say. There, I also started building a lot of standardization, especially AutoSAR is something which I started there and started building a lot of tools. And nowadays, most of the tools which you might buy through Bosch or ETAS, the first seeds were something which I worked personally.
Oh, wow.
So that's something which I am proud of. Then later I joined KPIT. I was also into software product development and building a lot of their AutoSAR products. And then moved into technical sales, or it was also called as subject matter experts, SMEs. Traveled around the world, sold a lot of KPIT's products. Traveled like in Japan, China, the whole of European countries and US and so on. So that's something which is a good achievement and learning for myself, like coming from engineering to also understand business development and relationships and how to manage that.
Certainly.
Yeah, that's true. And then in the startup, I also had a couple of patents as a CTO and driving the IoT engineering activities. Then I moved to DXC Luxoft, and now I would say from an achievement point of view is to really work global. I already told you about that we are in 22 countries. So working with diverse cultures and getting the best out of people and putting the right mix of talent to really excel in the engineering goals. So that's one of the big achievements, I would say, within DXC Luxoft.
Certainly, obviously fantastic, and worked with some great businesses there, and obviously everyone within the automotive field to know how big the impact of AutoSAR has been within the industry, and still plays have an impact today. So really interesting for me to see you were one of the early implementers and designers of that tool, which has been used everywhere across the industry. So yeah, fantastic, and some great achievements there, and thank you for sharing them with us. And also, yeah, really now just pressed on it many times with a podcast now, with how globalized the industry is and how you've got to run with we're running with different cultures, different ideas, different approaches. But ultimately, how bringing all this together is a unique but fantastic challenge. And I don't know, certainly your viewpoint, but people have told me previously, when it goes well and you deliver these global products with global teams, the actual innovation in the products and the way things are done is something that would have never been felt of previously if we were just siloing in just a particular country or part of the world.
Yeah. That's true. I think the key challenge, it's about the technology, obviously, the engineering
allows you
technology
to do it,
which has to be built is immensely complex. Yeah. And also working with people and making sure that everybody understands the complexity, because mostly if you understand the problem, you are able to solve it. Yeah. So many times people don't understand the problem. Yeah. So really working with great talent and building this right mixture of teams is key to success.
Perfect. Good. Okay. Well, jumping on to the next section then is learnings. And obviously, if you're going to look back at your career, obviously meet yourself at 2021, what key learnings do you wish you knew then that you now know that you think would be of interest for our listeners to maybe be aware of?
One important key learning, I would say, is almost what all we learn in schools or colleges, especially the science and the mathematics which we learn, that can be applied in day-to-day life, and really drive your life better. Yeah. So to give you an example, I learned the Nyquist theorem in college, but I didn't have a great understanding for that. But then as you go and interact with people or technology, then you figure out, oh, this can be applied on a daily basis. Like, if you want to control something, you have to be twice as fast as what you're trying to control. So best example would be if you're driving a car, we can drive a car at 100 kilometers per hour and it feels that you can easily control it. But imagine a sloth trying to drive a car. It's so slow, it cannot react. Yeah, so we know these principles and we learn them, but the way we apply them is what is an important learning. If you ask me, that's a great learning which I had, and I'm trying to build upon that. Yeah.
So basically, it's actually the theory that you said, a really interesting point there. So the theory that you actually learn in like the basics of like science or the physics or chemistry works or even mathematics, we use them in theory. Yeah, they're implementing some points of it engineering in areas, but actually implementing in day-to-day life and understanding those restraints and applying that theory to the world is actually a big learn for you. And you feel like if people applied that and did that soon, it would be a huge benefit on all areas, because there's also limitations in some things as areas that could be designed. Is that what you're trying to say there?
Yes, that's true. And the learnings, I mean, the learnings are also not always easy, because it's hidden in plain sight. You know it, but you don't know how to apply it. And so from that perspective, it is important to know these learnings and also to apply them. Yeah, to apply them in the right areas. Yeah. And another important learning, I would say, is to be persistent, because many a times we try to learn things, and we are applying them, we are pursuing them, but we give up in between. Yeah. So the more persistent we are, it's a important asset, I would say, to follow through in life. So, for example, if you're a young engineer coming out of college and then you learn something like how to write code or how to test it, and you are applying that and you have some failures, right? You then see these failures and then you're like, oh my God, you give it a shot, you maybe twice and then you give up. Yeah. But if you're persistent enough, then this is very powerful from a human perspective to really perceive. Yeah.
Of course, it's obviously not, especially some of the complex problems or other areas, you're not going to solve them first time. It's that consistency, isn't it, to keep going, keep reforming on your wrongs. And one thing, once again, really interesting that SpaceX and Tesla, I always hear mention that like actually when things go wrong, that's actually really beneficial to them, because you can understand and study what went wrong, and that's what's going to allow you to try a different solution next time, I suppose, especially in the modern day world where the data's there and almost everything can be monitored. It gives you a good opportunity to do that rather than many years ago. I know Newton with electricity, I can't remember the amount of times he tried before he developed that solution. So certainly agree, just because something's not applicable right away doesn't mean it can't get there, and certainly nothing seems impossible in the engineering world. We just need it takes time and the technology to get there too. Perfect. Okay, great. So then next section then is section 5, which is over to you, and this is where we give our guests the opportunity to talk about a particular subject or technology or something that's of particular interest to them that they feel may be beneficial to our listeners. So I'll let you introduce the subject. What is it you're looking to discuss today?
One of the important revolution, I would say, which is happening around us is supercomputing. I mean, we see the outcome of supercomputing, which is AI. We see the AI revolution, or keep hearing this word everywhere. But the underlying revolution, I would say, is supercomputing, because if you really look at history, supercomputers existed. I think it was already there in 1970s, 1990s, and so on. There has been evolution of supercomputers. But it was not available for masses. So you had to spend a lot of millions of dollars, and then, it was available for nuclear research and so on. Yeah. Now it's available everywhere, and it's really revolutionizing the way we think about the world and the way we build software and the way we control things around us. Yeah. So that's an interesting topic which I would like to talk about. Yeah.
Perfect, and the advantages, obviously, the power that brings. But great, a fantastic subject area, very relevant, an area that I know to some extent, but I'm not the most detailed on. So I'm really excited to hear these viewpoints from yourself. But where do you want to? Where would you like to start within that subject? I know we could speak for hours around it. To summarise in a 15-minute brief period is going to be quite an interesting task for you. So where would you like to start?
We can talk about the power of these supercomputers and how this is also disrupting mobility industry. So that
Perfect.
And then talk about the applications of it.
Okay.
So as we are talking, I think we are using our laptops or PCs, and this has some computing power, yeah, and it's roughly around 800 or 900 teraflops. So that's how a computing power is being calculated. That how many operations you are able to do within a second, yeah.
Okay.
And supercomputers are somewhere you can do petaflops of calculation or even much higher calculations, because they are multiple laptops or computer connected in parallel, and you're able to, like, imagine 1,000,000 computers connected in parallel, and you're trying to give it a job to finish, and then you need really complex operating system which takes this job, breaks it down into all these millions of computers, gets the input and output, and then you have to process everything together, right? So there is this complexity of supercomputing which existed. At that time, it's so expensive, you could only apply it on large problems. Like if you are building a nuclear bomb, you want to simulate a nuclear bomb before you actually want to
of course.
go to the field and explode it. So then you always use these supercomputers to calculate, and that's the way it was done in the past.
How, if you don't mind me asking, how obviously I know now one of the great things, they are achievable, a lot more affordable. I just saw the CEO of NVIDIA at CES this week announced that very adaptive chip for robotics. But how costly are we talking? Like in the hundreds of thousands, millions previously? Like if you estimate how costly were the computers of this capability?
So imagine in 1990s, a supercomputer which costed let's assume around 30 million or so.
Wow. Okay. Yeah.
And imagine you can do that in $200 now.
Yeah.
You spend $200 and you have the same computing power today. Yeah.
Wow.
And that's the power. Yeah. So you can see it's not even 100 times, right? It is even much higher. So the cost, the compute power you are able to do, or the amount of parallel computing you are able to do, is tremendous. And on the other side, I also have to say, earlier the supercomputers are built on remote location covering hundreds of acres and nothing moved and so on. But imagine automotive, right? You're putting it in a car where the temperatures can vary from -40 to 100 degrees, or the vibration inside the car. So you cannot imagine a lot of supercomputers put around that small area with all this environmental or terrible environmental conditions, right? And now the supercomputers are not just cheap, but they are also sophisticated, that they can reach all the safety requirements, which are
huge,
which are primary needs of automotive industry as well. So you can imagine now. So this kind of power is available, but then I think, as said in Spider-Man movie, with great power comes great responsibilities, right? So you have to really figure out how to use this power and how to really get benefits which are useful for the whole industry and for the whole humankind.
And it's just an example, isn't it, of like the evolution of the better performance of technology, the semiconductor industry, the chip capability from that 35-year span, that now you can have something that's can almost fit in your hand, that can do stuff now. She said that cost £30 million investment previously, and was probably a whole data center or a whole enormous structure of all these computers connected to do it. And the opportunities that offers is vast, which is exciting times, slightly scary, but exciting times. Okay, and then now with that adaptation and that advancement in supercomputing, especially in the automotive industry, what's the benefits? What's the changes that's offering? What's the other areas that benefits almost?
So the way normally, I mean, if you look at normal computing, we always went by programming or instruction. We are saying the computer to do one after a time, like do this task, then go to this task, and then the next one, and so on. So it was quite sequential, and you have to have a lot of engineers understand the problem which you are trying to solve and break it down into instructions which the computer can understand, and then provide the right input, right environment. And this has been always the way we have been developing software. Yeah, I mean, it's not limited to automotive, or if I talk about manufacturing, or if I talk about defense or any other equipment which we build, this is how we have been trying to solve the problem. And with such supercomputing, you always need not have to tell the computer or give the instructions how to solve the problem. Rather, you could tell the computer what is the outcome you are looking at, yeah, and then allow the computer to learn and build by itself, yeah. So now you see, I think the primary example is autonomous cars, right? So we are seeing that the car, you're not writing instructions to really tell the car what to do, but rather we are building the system in such a way that the car itself decides and learns, but then we are monitoring the system and saying that, okay, you're doing a good job. This is exactly how a human driver would drive here, or, and vice versa. So the problem is really moving away from
sequential command.
Writing
is more
instruction,
like
sequential instruction to learning systems. And this has another interesting impact. Most of the problems which we solved in the past, we can solve it much better, and it can be very cost effective. Because obviously, yes, the supercomputers will increase the cost of the equipment, but the problems which we are trying to solve and the amount of time we took to solve that problem, it was quite large. And now these problems can be solved much faster, and the overall system cost will go down.
So the cost is quicker, the performance is better, the solutions being provided is quicker. Almost, it's always allowed, as you said, the way computers have worked from sequential now to where they're not the same capability as a brain, but they can, from the inputs, decide and make decisions themselves, and we're monitoring that, which is like a whole new way of working almost to some extent.
But interesting, you use the word brain, and that's how the new architectures are called. It's called brain-spine architecture. Yeah?
Okay.
And that's how the systems are. Earlier, it used to be a small instruction executor, let's call it that way. But now we are building a lot of brain-spine neural network kind of architectures and writing software for such systems.
Replicating like almost how, as close as we can, how like a human body works. I know, as example, the spine's ultimately the thing that travels all the neurons down to make the actions within the body from the brain. We're now trying to replicate that architecture and actually are making progress within it, which then gives endless possibilities.
Exactly. And that's actually what is really exciting. And that's what I would like to tell to the listeners, that the industry is changing, and there is unlimited potential which is being unlocked right now.
Yes, and it's almost now, because due to the developments of the technology and being where it is now, especially in recent years, that things that would have seemed impossible 25, 30 years ago are now definitely possible, or there's a track where we could maybe potentially get to there with the continuous innovations, isn't there, really? Like, this is a game changer ultimately.
Yeah, that's true. Because the technology, as I said, the technology also existed in 1970s, but whether you were able to apply those technologies in the field of area where you wanted, that was questionable. Yeah,
too costly, right now, the infrastructure needed. Yeah,
exactly. And even we talked about something like the vibration and also the temperature requirements. Right, those problems were not solved and not solved at scale. And now a lot of industries cooperating and collaborating. Like, for example, NVIDIA is a good example. Qualcomm
work with everybody. Example. They work with everybody.
Exactly. Then they try to solve this problem for, cloud computing, and then they did it for OpenAI, and then they also brought those technologies into automotive industry, now taking that to defense industry and so on. So there is a lot of collaboration happening on base technologies,
which is a good thing.
And also, we only see NVIDIA, but maybe there are other companies behind, like ASML, or even the companies
AMD.
which are actually manufacturing the lithography machines. that's a whole new ball game where those technologies are driving much more innovation, which helps us to reach all this.
Yeah, and interestingly, obviously, the other industries have always worked close together, but it seems now like the industries are working a lot more in partnership. You said that the semiconductor industry is working extremely close with these other industries, and then almost that's now reflecting now that typically previously you'd have a lot of the OEMs that would work in competition away from each other. They're almost now called like working within partnership, aren't they? Because the solutions they're trying to solve are either so need such a large financial investment, I'm assuming, or the problems are so complex that the more minds that press on doing it, and then when they solve the benefits there, which is a change, I would assume, from what it was like 25, 30 years ago, once again, when it seemed like people tried to be a bit more siloed within that time. Correct me if I'm wrong, that's just my interpretation.
Oh no, that's again a very interesting point, Luke, what you're mentioning. As we said in the past, we were doing more sequential, so there were multiple distributed teams, even within the OEMs or even within the software, the tier one companies as well. And so the focus was they were quite divided, right? They were quite. I'm not sure if silo is the word. They would still call.
Is that the wrong word? Sorry.
Yeah?
Sorry.
No, but they had their own departments. Let's say they had their own departments, and they had the clear focus of, this is my portion, and let me focus on this. And as we talked about supercomputing, now you are able to get such high compute performance. You don't have to implement everything, or every problem doesn't need an electronic control unit, and suddenly you need one large supercomputer like the BrainSpine architecture, and then you are able to deploy applications on top of it. And this means that the challenge is actually the organization. If a company is still holding on to their old organization structure where they had a lot of departments and they were not working together, and imagine suddenly you are trying to roll out all these new technologies, but you still have the old departments and organization structure, then it's, as you said, you need to put a lot of money and you need to throw a lot of engineering power to make something successful.
Yeah.
But so the big challenge would be to reorganize yourself as the technology is changing, reorganize yourself. And you see that, I think in the news, you keep seeing new organization structure or new software companies being formed by OEMs to readjust to the new reality. Yeah.
Yeah, fair. And then obviously with these new technologies, new learning you need to have, it's probably a new way of working. So as an engineer, you need to continuously be training. But I imagine now more than ever is that emphasis, that learning and that adaptation needs to happen. Or if not, you'd probably fall behind the technology in a really quick space of time, won't you? Now, I know previously, correct me wrong, it used to be like 5 to 7 years. Now the technology turnaround can be 12, 18 months, and that constant learning and development of these new spaces is needed, or what has been used previously for 20 years has probably gone within 2.
Yeah, that's true. I think that's absolutely true. And we see that in the amount of cars and amount of features being rolled out. I mean, obviously from Asia or even some companies in Europe or in US, the pace at which they are able to adapt to all this demand is amazing. But then, you need this top-down understanding of what is the underlying technology which is driving it and how effectively you are able to use it.
And then that's in some ways going back to one of your key learns from earlier, isn't it? It's the fundamentals. Ultimately, it's the technology and the fundamentals that is allowing this to happen. And why is that? And that's great. Okay, fantastic. So with supercomputing, then before we move on, obviously complete change of doing it. With that trend, well, if you were going to feel, how do you feel that's going to look for the medium to long term? Like, what opportunity is it going to offer? Vast opportunity? Is there any concerns around that? Just give me a brief overview of that before I move past this subject.
Yeah, no, I think for the industry itself, it's a huge benefit, I would say. I mean, as I said, it's also not limited to just automotive. I also see that in manufacturing or defense or any mobility and equipment manufacturing company. Everybody will be disrupted with this trend. Mm-hmm. And it's a huge opportunity as well, because what we are already seeing is the equipment cost, the final equipment cost will keep dropping because of this disruption. Either the amount of engineering effort needed to do something, this goes down, or even the amount of features you can deploy for the same cost is also much better, right? So you're able to achieve more with the same cost as well. So what it means is you are able to deliver higher value to the customer. Yeah? And this is a huge opportunity. Let's assume, or I'll take an example to give this overview. We all know about Netflix, and before Netflix, we had CDs, right? If you want to watch a movie, you ordered a CD, and it take like 2-3 weeks, or you have to drive down to a store to buy this
Blockbuster. And you'd have them, and you'd put them in your DVDs or your Blu-rays, and you'd have a DVD collection. This makes it sound odd. I do miss having a DVD collection a little bit.
That's right. Then you know the pain of this, right? So I mean, the new generation kids probably have not even seen it, but I just want to give you this example because at that point in time, the equipment, the DVD players, the DVD itself, there was huge cost which was being spent, and then comes internet, and then you suddenly see that the 4 gigabytes of DVD can be downloaded in a few minutes. You don't really have to drive down, and suddenly the whole business model and technology model, it really went from equipment to subscription.
Yeah.
And this is something which I'm really curious to see. It's happening as we see, because the cost of producing a car or any equipment or even building a factory, right? This keeps going down.
Of course,
Yeah. And what it means is the business models which we are used to will go away. Yeah. And you will see new business models. I can even give an example in the car industry. I don't know if you know this company called SICT, which is where you can rent cars.
What were they called? Sorry.
SICT, SIXT.
Okay. Yeah. Of course. Yeah, the car rental, the enormous car rental company. Yeah, of course. Yeah.
Yes. Now you can actually rent a car. Instead of buying a car, you can go there, walk in, at least in Germany, and you can say, "Oh, I would like to rent a car for a month, or I can rent a car for 6 months." Mm-hmm. And this was not possible. Let's say you rewind it like 10 years before. Yeah. You cannot go and just rent a car because you have to think about insurance, you have to think about maintenance, you have to think about all these costs associated with the car, and you needed human beings to really look at it and take care of the car and own it, and you had this ownership relationship as well, right? Mm-hmm. Now the cost of a car is also going down drastically. This is allowing us to think about the way businesses are working. So I feel the automotive industry, especially, there will be a change. And you'll see new business models coming out.
That's so interesting, isn't it, from a model that's been set in place for so long? And obviously, the automotive industry is probably already 10 years into one of its greatest innovations ever, but that innovation just keeps extending into new areas and the overall way we work with mobility. And, just insight for something, are the prices of the factories and everything to build the cost just because, for example, we're able to automate things more now? Like, just from my own personal understanding, from your viewpoint, why is it the cost of the factories and building the cars is becoming cheaper? Is it because the components are better or the automation that's coming in? Like, obviously, that's quite a complex question, but from your feeling, what is it that's allowing the cost of these vehicles and overall systems to decrease so much?
It goes back to the supercomputing and the AI power which comes on top of it. So let's again take an example. Yeah, imagine you have designed a really amazing car, but then now you need to produce it. So earlier you put a lot of employees and teach them like exactly how to move the component or how to carve out or how to screw it and so on, and you built a massive factory. Mm-hmm. And then obviously automation came where you can say, oh, this is a repetitive, boring task. I build a robot or a stupid robot, I would say, which can do one job, right?
Non-stop. Yeah, non-stop.
And then the focus was, oh, I could remove 5 employees from the production line and replace it with this one repetitive robot, right? And so on. And so there was a lot of automation which I went through as well. But now what has happened is there is AI which is going into manufacturing, where you have robots which can look at what you are doing, and then it can learn this activity and do most of it. So you don't have to sit and program this robot. Like earlier, you had to program it. You had to write this instruction one after the
So
other.
it can just observe. So it can just observe what we're doing as we're doing it, and then because the inputs in the brain, we create within it, it can then go, okay, I can do it this way. I've seen this with like Figure and
Yes.
Tesla Bot to some extent, but
Yes.
okay, fantastic. And
this is very powerful, yeah, because we talk about AI, which is like the chatbots, right? But there is also AI coming into this world, and NVIDIA called it physical AI, right? So really, AI being applied on physical world problems, right?
Yeah.
And now you see a lot of robotics happening where you are able to automate without spending a lot of energy in teaching the robots. Yeah.
Just a quick count up before I move on. Are the costs of making those, obviously, it's great and that's what allows us to save costs, but are the costs of making those robots not astronomical or like, obviously the counter, but always the cost of the, like you were saying, because of the AI over time, the cost of those robots is going to keep coming down because as we manufacture more, we get better at doing it, the costs get more affordable, and then that's also going to bring everything else down.
And also there is some amount of, I would say, democratization of this technology. Okay. You can see that. Like I can give a good example of NVIDIA. Like for example, earlier, if you want to do level 2 autonomy, let's assume you want to build a car and you want to reach level 2 or level 2 plus and so on, you have to have your own team. As an OEM, you have to build a huge AD team, or you have to work with a software or even hardware tier 1 where they build all this technology, and you have to buy it from them. But now if you look at NVIDIA, they are able to give this NVIDIA drive stack by themselves, and they are also certifying it for safety, and it is already reaching all the safety standards and TÜV certifications and so on. And the business model is also you pay them when they reach the level 2 certification, right? So interestingly now, you don't have to, if I'm an OEM, I have two options, which I didn't have in the past. Earlier, I always had to think of building my own team or to buy a product from somewhere else. But now I have the option that I can go to NVIDIA, which is not only solving my AD problem, but I can buy a SoC where I can deploy the level 2 stack. Plus, I can put more software on top of it and achieve other features as well, which was not possible in the past.
This streamlining everything as well. So as well as doing that benefit there, you're not needing as many components or separate businesses because the power of the AI is allowing it to come under one roof. And these are complex problems that are coming. Wow, fantastic. Okay.
So you can, and the same thing happens. This is just an example. The same thing is happening in all the industries. So what it means is then all the businesses have to rethink the way they used to do business. Oh, I was selling one component. I was making money from one ECU, 5 sensors and so on. And suddenly, there is a breakdown in the way we used to sell and the way customers are buying from you. And this is disrupting, and some companies are struggling to deal with this reality. But many companies are adopting, and then they're saying, oh, I need to think differently, and the way I engage with the customers change.
Like anything with innovation, there's huge opportunities, isn't there? There's huge opportunity in some ways. There's new players that come into the market, whether it's in automotive or other fields that took advantage of that opportunity and come to doing it. And then like anything, you'll have some other players that have been around for a period of time that haven't adapted as quickly or are struggling to change their model towards it. It's the pros and cons. But I also just feel from a personal viewpoint with that capability there, it also is going to probably create more competition, but over a period of time, it will probably. My feeling will be that the typical OEMs we see will change, or will there be as many? You don't know, but that's that comes with innovation, which is a fantastic opportunity. But there's always winners and losers from that.
That's true, and it's not only NVIDIA, right? We also see that with Qualcomm, or we see it with NXP. Or I can keep naming a list of semiconductor industry which is driving this, and obviously, all these semiconductor industries are also powered by their foundries and their partners who are also innovating at the same time, and they are also democratizing their technologies. And so it's not just one player. We see that even AMD, Intel, everybody is trying to catch up to this game, and it will be a fun time to see for the next 10 years. How this pans out.
Yeah, no, fantastic. And literally, I could have you on the podcast for 2 hours just talking about this. It's so insightful, but we do have to move on. But I think that's, yeah, a fantastic overview and like touched on some of the fantastic opportunities that we have. And it all leads back to the supercomputing and the SoCs that you then use in the industries. But yeah, thank you for that overview, Sugandar. Very insightful. And I think most of our listeners will really enjoy that overview we've just discussed. So thank you for that. Moving into the next section, then it's section 6, technical tips. And it's more just following on from what we've just said, from your viewpoint, if you're going to look at the automotive or future mobility industry in the medium to long term, are there any particular areas or skill sets or things that you would recommend our graduates to pay attention to or to learn within? Because A, it will either allow them to have a fantastic career opportunity, or B, because that skill set or area is going to make such an impact, they're going to have to understand it well because it's going to come into the work in day-to-day life so much.
Yeah, we talked about supercomputing, so that's obviously an
number
area.
Yeah, number one.
But it's also a huge area because it's very difficult for one person to master everything. There is
the brain has limitations, whether you like to admit it or not. It does.
Exactly. The neural networks, the AI software or machine learning, which we try to build on top of it on the supercomputers, or even just building the platforms, they are also quite complex. So from a technical point of view, I would recommend the graduates to really look at this technology and also play with it. I have to say this because when I studied, it was very difficult to learn, or even you have to find books, find libraries, and you don't find podcasts of people talking about things, right? So it was very difficult when I studied. So now, if you're a graduate, I would say there is a lot of access to information and try to learn these technologies. You don't need a formal course to learn this. And then apply also, because you can also build things on your own and apply these technologies by yourself and explore it. So this is one area which I would highly recommend that they look at.
Okay.
And the other trend, especially when I look at mobility, is even the way data is being moved from point A to point B, right? So, which is a common challenge. It is also a challenge which goes beyond industry levels. Whether you are building cloud computing, whether you are building equipments, the challenge of data and the data loop, how it's being processed. This is another interesting area where the graduate engineers could look at, and probably they are already studying this in their curriculum and explore this a little bit more.
It's just for supercomputing one, so the transmission data is another key area around doing it. Just to get your viewpoint and ideas, touching it when it meant earlier, because of the innovations in technology so much, your viewpoint around the basics and where they can be implemented, do you feel that we'll still have the need for real strong specialists in all areas like we have in previous years, or do you think it's more, as you're going to guess, it's going to be more of like a strong generalist overview where you have to have a knowledge across a range of areas and it's how you apply that? Like, do you feel there'll be a large requirement for real true specialists in the future if you were going to guess your feelings?
I think that's a good question. The amount of generalization which is happening is high. The reason is again AI, which is something
allowing that to happen
within our company. Like I can give you an example. Earlier we were hiring a lot of engineers to do AutoSAR configuration. Now we have an AI system which is able to configure by itself, and then we are training the AI how to do this, right? Mm-hmm. So what happens is suddenly a specialist of AutoSAR configuration, he is not, the knowledge earlier was very valuable, but now slowly in the future it goes down in value. Mm-hmm. And this is not just about AutoSAR, but you can imagine if you're an excellent C coder in the past, and now AI is able to churn out C codes much better, right? And so on. You will see this trend almost in every area. So more generalized knowledge helps that. And how do you apply this knowledge onto an engineering problem? That's what matters. Because you always have an AI agent which will help you, but then you should understand the problem and how are you able to apply this skill on top of a problem and trying to solve a problem. This is what is very valuable. So knowing more generic stuff and knowing a lot of broader topics is very valuable. Yeah.
And that's once again a change that we've seen for many years. It's potentially coming, and it's more leading back to your point of understanding those engineering fundamentals. If you understand the fundamentals and you also understand how to engage and communicate with these specialist AI bots, and you can use the knowledge that they have with your knowledge of the fundamentals, you'll probably be able to solve and identify problems quicker, won't you? You're almost like working in partnership with these AI bots that we're
Correct.
developing.
Yeah.
Amazing. Okay.
And if you see the curve of development as well, like the supercomputers are leading into a lot of agentic bots, and then the agentic bots are also leading into a lot of physical AI, and this is how the graph is moving. And I think the education system, I'm not sure because I'm also disconnected from the system, but they have not yet kept pace with this technology growth, and that's where I think there's a big opportunity for the graduate students to really look at this and learn and be prepared for the future.
Of course, and it seems like the education systems, from our understanding, haven't been able to move as quick. Because to be fair, that's a pretty hard task to do, I imagine, with the pace of the technologies moving at to keep up with the infrastructures is there. But if you know the fundamentals, and then with the internet, you can go train, you can explore with these things. You're going to have to self-teach yourself, but the opportunity of doing that is vast and great. Okay, yeah, fantastic, for very exciting points raised there. I wish I was younger.
That's a good point, because I have to say this, even within our company, that's actually one of the important challenges which we address. We provide a lot of training program and upskilling program. We call it upskilling, right? Because we try to reskill a lot of people who are used to different way of working, which is good, but then the new age problems and the new age systems are totally different. So you really have to learn. Mm-hmm. And what I want to say with respect to being young, right? If you have already worked for 10, 20 years in a particular way, and then suddenly there is disruption, it takes longer time for you to learn. Because you are always asking this question, right? In your mind, is this right? No, I could solve this problem in a different way. But you have a lot of baggage to carry.
Yeah, it's almost like you have to unlearn things, don't you, that have been ingrained in your brain, a certain way of doing things, and now there's a better and more efficient way. It's doing it and then understanding that and the fundamentals, and the opportunity is vast. And there obviously are people doing it, but yeah, I do certainly agree. If you're starting from scratch, it's easy to pick things up rather than a different, more efficient way to what you're used to, because it's almost like two parts of your brain arguing with themselves. No, fantastic. Very exciting times, obviously, great times, and it's a really fantastic opportunity, as you mentioned, for the youth and the next generations. I'm really excited and wonder where this technology will be in 50, 60 years. It's crazy, but that's for another day. Okay, so great overview there, and then we'll move on to section 6. And I know we have touched on some of these points again, because supercomputing is going to keep up being mentioned everywhere. But from your viewpoint, where do you feel the mobility industry or the industries are going in the medium to long term? Like, what is up and coming in the future mobility space due to these technologies?
Yeah, I think we touched upon this briefly. So the important change in mobility industry is the cost of the equipment. Yeah, right. So either this is the produced equipment, or even the machines which are producing the equipment, this is going down, which means for end users, right? So you'll have more options, you'll have new features, you'll have exciting products to buy in the or to subscribe to in the future. So that's an important change. But there is also a broader, I would say, change is you are able to look at the mobility industry, which was primarily focused on solving the problem of people moving from point A to point B and then providing them tools to do that. And what I see is probably there might be innovation and companies which come together in terms of solving the problem of moving from point A to point B, but from a business point of view, where they come and say, oh, you have a subscription with me, but you can travel around the world and you can pick a
car up anywhere, or that makes sense. I could see that.
Yeah, so this is an important change where you can see a railway company collaborating with a car company, collaborating with an aeroplane company, and so on, right? So this kind of innovation which will come, because then people will start seeing the problem, because if you're waiting in an airport for 2-3 hours and then you have to rent a car, and then imagine the amount of processes a human being has to go through. It's painful, and the only reason it is painful is all these companies don't cooperate right now. Yeah? And now mobility as a sector will be forced to cooperate because they would be fighting for providing higher value than what they are providing today. Yeah. And then you will see interesting change which is happening. This is very long term, but in the medium term, in the medium term, what I see is the technologies which we already have, for example, the autonomous car or so on. So there will be price drop because you will see you'd find two cars from different manufacturer, one costing, let's say 2x, one costing x, and then they are quite comparable. And you will see this happening quite a lot. So there will be many new players who are challenging the existing players and so on. So this will happen in the medium term. You will see that there is huge cost pressure in the mobility sector. So, and that's one of the things which we are trying to address within DXC Luxoft. Exactly looking at the value proposition which we can bring into our customers and try to solve this problem for them.
Of course, it's a benefit to everything getting cheaper, everything getting more affordable, technology being able to compete with each other more. Once this is a generation thing, that in the next generations, more brand loyalty is nowhere near what it was with previous generations as well. So the impact within that space is vast. And then also, I imagine, because if the cars are getting cheaper, it means if we do crash, the cost is lower with the insurance company, so that should come down. If the cars are getting more cheap too, and as the autonomy comes in, I certainly do believe, I don't know when it will be, but at one point we will have primarily autonomous cars. That should reduce the amount of crashes. So the cost of that overall industry should just plummet, where it's a lot more accessible, which offers further opportunities. So very, very, very exciting times. And obviously, it's just how long will that take? And that's the thing that I don't think anyone can put the finger on, can they? No one can go out. I'm confident it'll be 10 years. There's so much, even if you've provided the solutions, there's so much bureaucracy and paperwork and terminology that needs to be agreed to allow these things to come into the world on a larger basis as well.
Yeah, and now the pace at which the change is happening is also quite fast.
Quite.
Earlier, the same change.
Understatement.
But I think it is, it's so fast that people are not able to wrap up their mind around it. And so I see that quite often. And many times it is also difficult to have this conversation because it's also disrupting the person who's actually in the field, right? So to say that, hey, if you don't change, you are out of job, right? So that's something very difficult to say. But on the other side, it's quite exciting, because you see the world, it will be really different. The way I think it will be like how the mobile phone industry disrupted the way we consume information. I think this would be another way the mobility industry will go through a similar change, and you will see a lot of reorganizations across.
Good. Obviously, all very exciting times of innovation, which is great. Okay, fantastic. I suppose moving on to the next question then. Obviously, technology is great. These opportunities are fantastic. From your viewpoint, is there anything that could stop the impact of this sector, anything that can slow down the progression of these developments, or anything that's slowing this innovation that is a potential threat to the future mobility space and things moving forward?
I don't see any threat right now.
Okay.
Maybe the threat, I think, is more internal than to the industry. It's more about companies and how they see it and how they approach the problem. But it's not an industry threat. And also, it's such a fundamental industry, right? So if I really look at it, mobility, like after you secure your food safety and other stuff, the first thing which you look at is mobility and logistics and transport. And we human beings are not only human beings, right? Even the small cell animals, everybody, the first thing which they look at is how to explore the world, right? The life could have been only in the water, right? They never had to come to the land or to go there and so on, right? So they always moved in exploration. So I feel mobility industry is going to continue, and you will see a lot of change.
Perfect.
And
okay,
I don't see any risks for it.
Love that. Okay, good. Great answer. That gives me even more confidence in the space. Okay. Moving us on to the last question on the podcast from yourself and your viewpoints is, why do you feel if they're a graduate, they should choose a career in the future mobility or automotive industry? Obviously, as we've mentioned here, the skill sets that you're looking to hire, every other industry is looking for them. Why, if you were speaking to the graduates that are listening, do you feel that, the future mobility or automotive industry would be the most interesting or the best for them?
I would prefer, again, in mobility, there are many industries, right? So there is aerospace, or there is automotive, and so on. But one of the key reasons why I prefer automotive is the problems which you are trying to solve are quite complex, and even the reaction times. Just to give you an example, most of the decisions, like if you want to deploy an airbag, we talked about it, it takes 70 microseconds, right? So then you are building systems which are reacting in microseconds. Yeah. So the complexity within automotive is quite high. So you get a huge opportunity to learn how, I would say, physics and how the world around you works, yeah, and have a good understanding of this and try to solve these problems. It's quite fulfilling, yeah, when you try to solve these challenges. Another aspect is when you look at automotive and then take those engineering skills and you are able to deploy them to aeroplane, because there probably it's not happening in microseconds, maybe in milliseconds or seconds, let's say. Like autonomy, if you solve it in cars, and taking the autonomy to other industries is, I would not say it's easy, but it's fairly
You've got longer time
knowledge.
gaps, haven't you? You've got longer time gaps. I imagine if you look at the aerospace thing, even those threats, you've got the aircraft aren't as close together. You've got probably longer times to react. And I know one of the other great things about the aerospace industry, when they created airports around the world, all the signs are consistent, aren't they? I know if you go in some countries, signs are different, and I'm aware of that there.
Exactly.
So it should be easier to implement, and because it's working at slower speeds, it should be, in hindsight, I agree with you, easier to implement, even though there will be different challenges.
Exactly. And what automotive brings is you have to solve these problems, but there is again tighter requirements on safety, quality, and how do you produce millions of those parts and remain at that high quality and so on, right? So the engineering problem which you usually address by automotive is quite niche, and then that's one of the reasons why I would say or the podcast listeners to look at and pursue their careers within automotive. Yeah.
Perfect. So obviously, thank you very much for that last answer. Obviously, thank you very much for giving us the time around those details today. I definitely think in the over to you section, it's by far the most interesting thing I've seen and heard in a long time. So really excited for that. And before we move forward, I know Section 8, you and DXC want to take advantage of that and just give a bit more of a company outlook and overview to our listeners that either graduates or senior engineers that might be interested in engaging with the business or learning more about the organisation. So I know you've covered this at points here and there, but do you want to give a brief overview of Luxoft DXC and what you guys do? And we'll move forward from there.
Yeah, sure. So I think in DXC Luxoft is a quite global company, and I think we already talked about it, that it is, even my own department, it is spread across 22 countries, and you can imagine it's quite global. So within DXC Luxoft, we really look at engineering talent, and we really don't care about the cultural background or the location. We really value the talent and the knowledge they bring in. And what we also, personally, myself as well, we are on remote working contracts, so we can really work out of any location or anywhere from the world. Yeah, and that's actually quite an attractive proposition, I would say. And then within DXC Luxoft, the amount of scale, because the types of customers we interact with, there's no boundary, right? So we interact with customers right from Asia or Europe or US, or even sometimes across industries, like whether it is automotive, manufacturing, defense, or even healthcare and so on. So the opportunities within DXC Luxoft is huge. So there is unlimited potential for us to work on really cool engineering problems, I would say. Yeah.
Of course, yeah, and obviously you guys heavily focus on supercomputing, AI, obviously heavily in automotive, but I know you do cover general manufacturing as a whole, don't you, and touch on other really exciting industries as well.
That's true. So we work with, obviously with automotive OEMs and tier ones, but we also work with a lot of manufacturing companies. So we help them in the overall workflow automation and then help them in becoming more efficient in their manufacturing process, and also help them in adopting their production lines and quickly changing from one to the other or from one application to the other application as well. Yeah. We also work with a lot of defense companies as well, where we help them in especially equipment manufacturing and designing the equipments and so on. So especially in my department, we are active in this three areas, but within DXC Luxoft, we also have healthcare, we work on banking systems, we work on insurance companies, and a whole lot of industries as well beyond engineering industries. Yeah. And we talked about computing, supercomputing, data, and so on. What we see is whatever we spoke about is disrupting all the industries. Yeah. So we talked about supercomputers earlier. Data and data management was not a big thing in automotive, so we are bringing in a lot of IT and infrastructure topics into automotive, and then we look at, let's say, a defense company or a manufacturing company which did not care much about supercomputing in their devices, and then we are bringing in those technologies there. So from this perspective, within DXC Luxoft, there is unlimited potential to really build your career and scale your career. Yeah.
Perfect. Okay, well, what I'll do for our listeners, I'll put the careers page in and potential key contacts in. Looks like DSC if you're looking to understand more. But that brings to the end of our episode. Sugandar, thank you so much for your time. And yeah, really, really insightful episode. I'm really excited to get the feedback from the listeners and the viewers. I think it's going to go down extremely well. Thank you so much.
Thanks. Thanks, Luke. It was a pleasure to discuss with you. Yeah.